Hi, in this video we're going to look at some performance considerations when we use the decimal class. So there are some drawbacks to using the decimal class versus the float class. Now we saw in previous videos why we might want to use the decimal class, but we saw that constructing decimals are not that straightforward. You have to use strings or tuples. So it's not as straightforward as constructing floats using just, numeric literals. So you have to be a little bit more careful there, and it's a little more tedious to create decimals. The other thing too is that not all the mathematical functions that exist in the math module have a counterpart in the decimal class. As we saw, some operations like, for example, square root, log, exponents, and so on do have a counterpart in decimal, but trigonometric functions do not. We also saw that the mod and div operators don't work the same way in decimals as they do with integers and floats. So again, just some things that you have to be aware of and sometimes be careful with. Thirdly, there's more memory overhead. Creating decimal objects takes a lot more memory than floats, relatively speaking. So if you have a lot of decimals that have to be in memory at the same time, you're going to use up more memory. Your memory footprint for your programs can be larger, and maybe you'll run into trouble. It depends. I mean, usually these days you have so much memory in systems that it doesn't really matter. But if you're dealing with a lot of numbers at the same time, then you could run into issues. And then lastly, performance. The performance of decimals, and when I'm talking about performance, I mean like arithmetic operators, the math operators, and so on, is quite a lot slower than floats, relatively speaking. Again, we usually have high-end CPUs that can run calculations very fast. But if you have to do a lot of calculations, then you'll start seeing that performance is really degraded when it comes to decimals. So again, just things that you have to be aware of. They're drawbacks. You can certainly use decimals and they can be really useful in certain situations. But if you're not worried about the precision, then you really want to opt to use floats. So let's take a look at that in some code and see how all that actually works. So the first thing we're going to look at is the memory footprint. So for that, well, first let's import our decimal class from the decimal module. We'll need that. And then we're also going to need the sys module, so we'll import that. And let's go ahead and create two variables, one pointing to a float, 3.1415, let's say, and the other one pointing to a decimal object with the same value in it. So here we have A and B, and we can look at the size in bytes. So get size of A, and that takes up 24 bytes. But let's look at the size of the decimal object. Get size of, and that is a whopping 104 bytes. So every decimal object you create requires 104 bytes, as opposed to the floats that require 24. So that's almost 5 times as much. So as you can see, there's quite a larger memory footprint required for decimal objects. The next thing we want to look at is the computational performance. And when you're dealing with floats, CPUs are pretty good at doing arithmetic calculations, and GPUs even more so. And you'll notice that there's definitely a degradation when we use decimals. So for that, we're just going to do some rough timing. Again, we're going to use the time module. So we'll import time, and we already have our decimal, so that's fine. And we're going to define two functions, and we're going to basically loop through doing something. The first thing we're going to look at is how long does it take to create a float versus creating a decimal. So let's go ahead and call this function def run float. We'll pass in a parameter n for the number of times we want to loop the same code, and we're just going to say for I in range of n, and all we're going to do here is just create a float. Okay, so that's our run float, and we're going to do the same thing, but we're going to use decimals. So def run decimal n equals 1, again just the default value for n, for I in range n, so we'll loop n times. A equals now decimal of 3.1415. Again, making sure we're passing a string when we do that. Okay, so now we have those two methods that we are going to time. And we're going to use a loop of 10 million. So we're going to loop 10 million times just so we can see a little bit more what the differences are. And now we have to start. So we do our start time perf counter. Okay. Then we're going to run float with n iterations. And then we're going to set our end time and we're going to read our perf counter again. Let me fix that up here. Okay. And then we're going to print and say that the float operation took end minus start, end minus start seconds. Okay. And then we're going to do the same thing again. So I'm just going to copy and paste this. But instead of run float, we're going to run decimal. Okay. So that should give us an indication of the fact that creating decimal objects takes quite a bit longer than creating floats. All right, so it took 0.33 seconds to run this method here, and it took 2.8, 2.9 seconds, 3 seconds, almost 10 times slower basically, to run the decimal version of that same method. So now we can do the same thing again. Let's copy paste this code. And I'm going to copy paste this code as well, since we're going to want to rerun it. But now, instead of creating the float inside, what we're going to do is we're going to create it once outside of the loop. So we're going to create it once, and now we're going to look at an arithmetic operator. We're just going to add a with a. And then we're going to do the same thing here. We're going to create the decimal here, and then we're going to calculate a plus a. We're not going to assign it to a variable or anything like that. We're not going to incur that overhead. That's not what we're trying to measure. We just want to see the time difference between additions with floats and additions with decimals. Let's go ahead and run that. And again, as you can see, 0.5 seconds for the floats, 1 second for the decimals. So, substantially slower. Basically, if you look at that, it's 100% slower to run the decimal. Okay, so that's for a simple arithmetic operator, and it kind of behaves the same way if you put in a multiplication sign. You get approximately the same kind of difference between the two, right? 0.49, 1 second. So that's fine. You can also look at division, for example, if you want. And it's going to be a very similar result. 0.5, 1.6, a little slower there on the division, which we probably would expect. Now, the other thing we want to look at now is the square root, some of the mathematical functions that are available in the decimal class. So let's go ahead and do that. So in order to do that, we're going to make a couple of changes here. I'm going to first import the math library, because we're going to need the square root function from the math module. And now I'm going to change the timing, the loop counter, I should say, to 5 million instead of 10 million. I don't want to sit here waiting for too long for the decimals to finish. So we're going to do the same thing here. We're just going to replace it with the square root. And here we want to use the built-in square root of the decimal class. So we have to use the instance method. So a dot square root. Okay. And those will be the two methods, the two functions we're going to time. So let's go ahead and run that. And there we go. The float took almost 1 second to run, 0.9. And I can keep talking for a little while. And that's why I changed that loop counter to 5 million instead of 10 million. I'm running out of things to say. So let's just wait patiently. There we go. 18.8 seconds. So as you can see, substantially slower when we did the square root function. And you'll find similar results when you look at logs and things like that as well. So these are some of the performance considerations when using decimals. Obviously, you don't want to use decimals just because you feel that, you want extra precision. You only want to use decimals if you know that you really have to have that extra level of precision and that you don't want these problems that we get with binary floats having inexact, infinite basically representations of our regular decimal representations that are finite. Like 0.1 is finite as a decimal representation, but it's an infinite binary representation. So if those are things that you need to code around, then decimals can work for you. But otherwise, stick to floats. They're more efficient, they run faster, they're easier to work with. All right, thanks for watching, and I'll see you in the next video.